Rational functions, multiplying and dividing. Okay, pause your video for just a second and write down everything that you need to for this part of the notes, and then resume your video to hear me talk about it. Okay, these are our steps for multiplying or dividing rational functions. First of all, we're going to keep flip change, or KFC, if needed. We only need to do this whenever we're dividing two rational expressions. So if we have a problem where we're multiplying them, then we don't need to do this step. Step 2 is to factor all parts. So we're going to look at all of the numerators, all of the denominators, and factor them as much as we can. Step 3, we're going to cancel out any common factors. We're going to find these on the top and the bottom. So if I have something in common that's on the top with something on the bottom, then I can cancel them out. In step 4, we're going to rewrite our final answer and state any restrictions on the domain. Okay, so in this problem we're going to multiply or divide. In this case, actually, we're just going to be simplifying these. So the first thing that we're going to do is we're going to factor any piece we can. This isn't a multiplying or dividing problem. You'll see more that look like that later. So the first thing is I'm going to see this bottom piece, and I can factor out a greatest common factor. So 6x is going to stay the same on the top. On the bottom, I know I can pull a 6x out of each term, and I'll be left with 2x minus 1. That comes after I divide each of these by 6x. Okay, now I'm going to look for something that's the same on the top as it is on the bottom so that I can cancel them out. I see that I have a 6x up here, 6x down there, so I can cancel those out. My final answer, I still have 2x minus 1 on the bottom. And since I've canceled everything out of the top, I'm just going to put a 1. So there's my final form. Down here I have x cannot equal. This is where we're going to put our restrictions. Something that you have to be careful with whenever you have fractions going on is what makes the denominator 0. So if we look up here in the denominator, we're going to look at it whenever it looks like this, our factored form. I see that I have two x values. So I'm going to figure out what will make each of these equal to 0. So first of all, if I look at 6x, I think 6 times what would give me 0? Well, that would be if x was 0. So x can't be 0. And then for the 2x minus 1, this might be hard to do in my head. I'm just going to set 2x minus 1 equal to 0 and see what value of x would give me 0. So if x were 0 or 1/2, then I would have a 0 in my denominator. So those are the two numbers that x can't be. Okay, same idea. We're just going to be simplifying this. We're not quite to one of the multiplying or dividing problems yet. We're just simplifying. So we're going to start by factoring. We're going to factor everything that we can see, starting with the top here. Notice that this is going to be easy factoring because both of my x squareds have a coefficient of 1. So I can do kind of an easy factoring method where I say what multiplies to 6 and adds to -5. So take a second and think about those two numbers. If you don't know the factors of 6, then you can just write the factors of 6 out. 1 times 6, 2 times 3. I can now see that if I have a -2 and a -3, those would add up to -5, and they would multiply to a +6. Same idea on the denominator. What multiplies to -15 and adds to 2. I can kind of use the top as a guide. There's a really good chance that one of the numbers I'm going to use here is either -2 or -3. I know that -3 and 5 would multiply to 15. And I can confirm that a +5 and a -3 would add up to 2. So those are going to be my factors. Now that I've factored everything, I can cancel out what's common on the top and the bottom. I have an x minus 3 on both the top and the bottom, so I'm going to cancel those out. And my final answer is just going to be x minus 2 over x plus 5. Now I want to make a big note here. We cannot cancel out these two x's. The reason why is because they are attached to something else with either addition or subtraction. So see how it's x minus 2 and x plus 5. If I look back up here, these x minus 3 factors were attached with multiplication. So that was multiplying right there. So again, you cannot cancel these x's out of the final answer. Leave it like it is. For my restrictions, I'm looking at the denominator. So right here. It doesn't matter that I canceled out x minus 3. I'm still going to consider it. So I have to figure out what would make each of these 0. I have two x's here. For this first factor, if x were negative 5, then that factor would be 0. And for the second factor, if x had been a positive 3, then that would be 0. So my two restricted values are negative 5 and 3. Okay, now we're going to be multiplying two rational functions. I don't need to do this KFC step because I'm not dividing, so I can just cross that off. I'm going to go ahead and factor everything. I can't factor x plus 7 any further, so I'm going to leave it like it is. I can't factor 3 any further, leave it like it is. I can't factor 15x, but I can factor this difference of squares. Hopefully that rings a bell to you, difference of squares. Anytime I have an x squared and a minus sign, and my coefficients are perfect squares, so 49 is a perfect square because 7 times 7 is 49. I can just take the square roots of each part, and I'm going to get x plus 7 and x minus 7. Okay, now that everything's factored, I can start canceling things out. Now think about this as one long fraction bar. Since I'm multiplying, I can make this one long fraction bar. These are all being multiplied together. I have an x plus 7 on the top and an x plus 7 on the bottom. Notice I can also simplify the 15 over 3. 15 and 3 are attached by multiplication, so they can be simplified out. I can divide both of them by 3. So if I do that, 3 divided by 3 is 1, and 15 divided by 3 is 5. So let's see what we have left. On the top I have 5x left. Remember this x right here, I didn't do anything with it. On the bottom I have a 1, which I don't really need to write, but I also have an x minus 7. So there's my final answer. Again, we cannot cancel these two x's out because the bottom x is attached to the 7 using subtraction. Okay, restricted values. If I look at my denominator, I see two x's. The value of x that would make this first factor 0 is if x were negative 7. And the value for x that would make this second factor 0 is if x were positive 7. Okay, again, we're multiplying, so we don't need this KFC step yet. First thing I'm going to do is factor everything that I can. X squared plus x can be factored by pulling out a greatest common factor. I can take an x out of both of those terms. Down here I can say what multiplies to 7 and adds to negative 8. Well, the only two numbers that multiply to 7 are 7 and 1. So it's going to be x minus 1 and x minus 7. And then on the right side, x minus 7, we can't do anything more with that. And x squared minus 1 is again a difference of squares. I know it's a difference of squares because the word difference means subtraction, which it has. 1 is a perfect square because I can take the square root of it, and so is x squared. So if I square root both of these, I'm going to get x plus 1 and x minus 1 because the square root of 1 is just 1. Okay, again, think about this as one long fraction bar. Everything's being multiplied together here. And if I look at this, I have an x plus 1 on the top and an x plus 1 on the bottom. I also have an x minus 7 on top and bottom. Notice that I have an x minus 1, or two x minus 1s on the bottom. I cannot cancel those out because they would have to be on top and bottom, not bottom, bottom. So if I rewrite my answer, on the top, all I have left is an x. And on the bottom, I have 2x minus 1s. You can write it like this, or you can write it like this, x minus 1 squared. Either way works. For my restricted values, I'm going to look at all 4 of these x's in my denominator. The first one, x minus 1, x can't be 1 or else that would be 0. The second one is x minus 7, so x can't be 7. The third one is x plus 1, so x can't be a negative 1. And then we have a repeated one, x minus 1. We don't need to write that twice. Okay, here we go. I want you to factor everything on here and then restart the video and see if you have the same factors as me. Okay, here's my factoring of everything. I see that I have an x minus 6 on the top and the bottom. I have x plus 1 on the top and bottom, and x minus 1 on the top and bottom. So what's left is on the top I have an x minus 5, and on the bottom an x plus 5. That's going to be my final answer. Again, can't cancel out those x's, or the 5's even, because they're attached to something with addition or subtraction. On the bottom I have 4 x's. So my 4 restricted values are going to be negative 1, 1, 6, and negative 5, because those are the numbers that would have made each of those factors equal to 0. Again, I want you to pause your video. I want you to factor each of these and then restart the video. The one factor that you might have had issues with was factoring the 3x plus 15. It's not a trinomial. It doesn't have 3 terms, so it's not like these. It's not a difference of squares, so all we're doing with that one is we're pulling out a greatest common factor of 3 in this case. Okay, so on the top, it looks like I've got an x plus 5 on the top and bottom, an x minus 3 on the top and bottom, and then what's left? I've got this 3, which is going to go out front, and then x plus 1 on the top. On the bottom, I just have an x plus 7. Your restricted values, I've got 3 x's on the bottom. So that's going to be negative 5, 3, and negative 7. Okay, now we're getting into some dividing. So we are going to have to use this first step of KFC. Keep, flip, change. Keep the first fraction the same, so I'm just going to rewrite this first one. Flip the second fraction and change to multiply. Now it's just like all the other problems we've done. We're going to factor everything that we can, which all that we can factor is this 4x minus 12. Pulling out a greatest common factor of 4. We're going to cancel out what we can and then rewrite. Looks like the only thing I can cancel out are these two 4's. They would divide out. So my final answer is going to be x minus 5 on top. And on bottom, I'm going to have a 9x and an x minus 3. Looking for my restricted values, I have 2 x's in the denominator. So x can't be 3 or 0, because 9 times 0 would have been 0. Same idea on this problem. You're going to keep, flip, change. So keep the first one, flip the second one, and change to multiply. So keeping the first one, I'm going to go ahead and factor while I'm keeping. This is a difference of squares because 25 is a perfect square. So it's going to be x plus 5, x minus 5. So keep, flip, we're going to have 8x on the top. If I factor this trinomial, I'm looking for what multiplies to 25 and adds to 10. It's going to be x plus 5 and x plus 5. And change to multiply. So now I can start canceling out. 1x plus 5 on the top cancels with 1x plus 5 on the bottom. I cannot cancel the other x plus 5. My two x's cancel out. And I can divide both 8 and 2 by 2. So I get a 4 up here. So my final answer is going to be 4 out front with x minus 5. And on the bottom, x plus 5. Restricted values, I have 1, 2, 3 x's in the denominator. So x can't be 0, because 2 times 0 would have been 0. Can't be negative 5. And again, I have another can't be negative 5. I don't need to write that twice. Okay, pause your video, try the independent practice problems on your own, restart the video to see my answers.